Hello viewers, welcome to my channel Science to Technology. In today's show, Camera Tuesday, we're going to talk about industrial cameras. So let's dive deep into it. Now first you have to understand, whenever a company is manufacturing something, they have a certain use case in mind. For example, industrial camera is supposed to run 24 into 7 into 365, meaning it's almost like a security camera. It's supposed to work. While similar standard exists for your security camera is not critical enough. Now again, they have standards inside them where it's like, the bare minimum. If it works, cool. If it does not work, meh. But there are like some serious one that is used for Pentagon and all that. Those are like, no, like it will work. So something that applies to everything. For example, A7 Mark V, it's not actually designed to run 24 into 7 into 365. Even though on paper I should be able to just like, put it below air conditioning all out and just like, plug it via USB. On paper it should be able to run, but it won't. It's not designed to do that. But when you are designing something for industrial customers, day one, every aspect, every capacitor, every resistor you're gonna select would be designed for that. Where it's like, hey, can I tank 24 into 7 into 365 operation? For example, on average, you are looking at 50,000 hours of runtime without any oops. That translates to 5.7 years of non-stop use. And that's average, meaning if your camera dies up, you're like, okay. That's not great. It's like, okay. Like you should be able to cross 10 years or 15 years. And yes, there are computer vision systems that are so ancient, the company that made them came and disappeared and the cameras are still working. It's normal. So fundamentally, it's a different beast. Another aspect is temperature. They cannot bitch about, oh, it's hot. They cannot. And generally they are designed for very wide range because a company do not want to manufacture different products for different SKUs. For example, one for America because cold is really cold in America, one for India where hot is really hot. They just want something that can handle that wide range, meaning minus 30 degrees Celsius or even 40 to very hot temperatures as like plus 50 degrees Celsius or 60 degrees Celsius. Generally hot is the main issue because these things consume enough electricity that they have self-warming effect. They will not gonna freeze over. So what about cooling? So cooling generally is done passively, not because it can't be done by a fan. It can be done and it will be very effective. It's just that fan will not last. Like you buy whatever fan, Delta, Noctua, whatever have you, every Tom, Dick and Harry, fan is the first thing that's gonna break. You need proof, look into servers. Every fan in servers are designed to be hot swapped because they will not last. So why? Well, it's a mechanical thing and mechanical things hate dust. Dust loves mechanical things. So this does not last very long. So even if you have to put a fan in your camera, people first will expect that it should last long enough that if fan goes out, it will scream, but it should function enough and then I should be able to swap it. And generally people will put air filter for this exact reason. So fan is optional. Nobody looks at it as like, hey, put a fan on it. Like, for a video camera, you're like, hey, put a fan on it. That's cool, awesome. But for industrial, that's not that awesome, especially because when you want years of runtime. And again, dust is real. So that's the whole point. And connectors. Once you have this puppy, you have power and data. Yeah, how strong are those? Those things have to be absolute because we are talking about factories. We are talking about things that are moving, meaning there is vibration, meaning there are harmonics, meaning there are resonance, and you cannot have oops. So vibration, harmonics, all of those cannot cause oops. Oops is not allowed. Oops equals no. If your equipment does oops, you out. So everything would be locking. Even if they have normal USB, you would be sure, like you'll always find that they will have like threaded holes and they will sell you the custom cable that allows you to lock it down. Like actually lock it down, like VGA cable, old school VGA cable. Power will always be not a barrel jack, it will always be a latching system. So oops is not allowed. Or you could have like, older school RS45, super robust connector. So that is there. Now, what about the cost? Even though technically the equipment that are going inside, meaning the sensor, let's say, be it from Canon, be it from Sony, the RAM chips and all that, basically the actual hardware, actual silicon is not that expensive. But the company will charge bonkers amount of money. These things are so expensive. Again, they have to be used for scientific instruments also. They charge bonkers amount of money. They are so expensive that none of them have prices. All of them are get quote, and they will study you to understand how much they can charge. Now, why would company put up with this? Well, the cost of the service is priceless, meaning what it does, it's like, yeah, I'm not gonna cheap out on that. So if companies like $10,000 for a hardware that's barely $2,000, even with margin, they're like, might as well. They're not going to fight it. So that allows them to charge a lot of money. And second genuine reason is that they're not going to sell a lot of them. The penalty of making something that lasts practically forever is that it lasts forever. So you're not going to sell a lot of them. And again, it's not like every Tom, Dick and Harry is opening a factory in their basement. So yeah, so prices are brutal. Now we come to the first selection, that is which shutter type. Generally, it will be global shutter. Why? Most factory have motion. Duh, like things are moving. So that is there, and you must inspect things while they are in motion. There are some older systems where they used to have a Geneva mechanism to, like, stop a can of jar and then capture photo of it and then compare. It's like, yeah, we no longer do that. That was like for very brief periods people tried that. It's like, yeah, that's like, no. So now you have to do all the inspection while you are moving. So that's the issue. Now, why don't everybody, Tom, Dick and Harry, uses global shutter? Well, global shutters, because they have capacitor that stores the charge next to the photo site. Photo site is smaller, meaning if I give you 24 megapixel rolling shutter, 24 megapixel global shutter would be significantly smaller. The pixel site, basically the part that is sensitive to photons, would be smaller. Even though they are the same size, like let's say full frame 24 megapixel, it would be different. How big of a difference? Generally, you're looking at 2 to 4 stops of dynamic range loss. So it is like, it will look like you are using an older camera. So loss of dynamic range is physically real, but you can control the scene. You are talking about you are not talking about a model shoot or a real world scenario. You are talking about a constrained environment, meaning if you are taking a photo, it's like, hey, the dark is getting too dark, you'll add light. If you're like, hey, the highlight is getting too brutal, you're gonna put an ND filter. Not ND filter, polarizer. Generally polarizers are used. And if you're like, hey, it's not feeling right, you will change the aperture, you will change the ISO. So you will do physical work to constrain the scene inside the camera's window, so to say. Camera has a dynamic range window, you have to constrain it, and ideally you do not want your things to be stretched too much. If you're like, okay, I'm inspecting solder balls, you do not want those balls to be like, okay, full dynamic range. That will waste computer's time to crunch through all the information. So you want to compress them or tune it that defects will jump out. It's like, yo, this ball is too shiny, this ball is not shiny enough. You want compression. You are helping the computer algorithm to do pass and fail. So you constrain the scene. Lighting is your friend, ISO control is your friend, shutter speed and aperture. Those are your puppies that you control in order to get within the program. You do not complain about, oh, does not have enough dynamic range. It's not the intended purpose. But sometimes, what if you don't have that, or the things are in motion, it's too goddamn fast. At that sort of time, you're gonna use strobe lights. You can see strobe light has the advantage of freezing motion, and on paper, it can make your rolling shutter behave like a global shutter. Does it work? Yes. And again, a lot of things do require this, like there is no way around it. But you do have to understand, strobe lights are not long lasting, meaning I can give you a LED lamp that lasts for 10 years without any issue in an enclosed environment. Can't give you a strobe that will last. So strobe lights, while they are used, they are a consumable item, like they will be consumed. So this is why more and more people are just pay the price of the global shutter. Like it's not worth fighting over. Now we come to scenario where you have 3 sensor requirement. Now why? Well, some things are what we classify as color sensitive, meaning when I'm saying this cloth is exact shade of green, it has to be that exact shade of green. It cannot be like, oops. So in those sort of scenario, demosaicing is not good enough, meaning the primary problem with your camera sensor, like this sort of camera, is that sensor is black and white. The actual silicon that is converting photon into electricity, it only sees photon. It does not see which wavelength of photon is there. So color is in the wavelength. So what do? We apply a mask to it. The mask is Bayer filter. The filter just basically was, if this pixel lights up, it was only lighting up when green light was passing through it. And this was red, this was blue. But that creates a paradox. You literally do not have full color image. You have green, that is 50% of the image, 25% of the image is red, and 25% is blue. What the hell? Yeah, that's the core problem. You do not have RGB, you have Bayer and black and white photo. And we do debayering algorithm to convert these pixel, what you call partially filled image into a complete image. A, it takes a lot of computation power. B, it's a mathematical guess. You don't know what's there. You don't have the resolution, the fidelity is compromised because pixel by pixel you don't have that. Like, so even though you're like, hey, I'm doing 4K, the actual color could be like, 720p and you're just stretching it. Now again, you do get a structure, but you don't get color. Structures is there. That's the good part. Bad part, color is not there. So if you are color sensitive, it's like, eesh, oof, not allowed. So if you are like, hey, I'm printing this, let's say cereal box, and it has to be this exact, which again, they are very particular about it. Yeah, at that sort of time, yeah, this is like, no, just no. So if you're talking about textile, printing, medicine, inspection sort of serious thing, yeah, no, this is no. So we generally do physics to it. Physics is, if sensors can only tell black and white, why not give them light that is pre-filtered? So we do prism. So the idea is trichroic prism. You can buy them in from Amazon. It's not that expensive as experiment. If you put white light through it, it will split the red on one side, blue on the other side, green on the other side. Now these are generally not used, but we use what you call a different set of waveguides. Those are far more precise and accurate. But again, this is the core principle of it. Light comes in, basically your lens feeds the light into the prism. Prism splits it into red, blue, green, and sensor has the full sensor. Basically, this would be full. This would be full. There will not be debayering. It would be all full. So even though on paper it would be like, hey, it's only 2 megapixel, but it's true 2 megapixel 3 channel image, meaning you have true colors, and it's not limited to 3. Most of the time you will buy 3, but if you require, you can have 4th added to it, which is infrared. Now mild infrared, be mindful, infrared is a long wavelength, and if you are looking into thermal infrared, those require different glass. That glass is opaque to optical spectrum, so you only getting like, subtle amount of infrared with infrared that can pass through same glass as a normal optical system. You can have that. In some scenarios that is required, if it's like, is the color bonding to the substrate accurately or not. Those sort of scenario, infrared is a very good at showing that. And you can even have ultraviolet. So you can have those lights also, and they're like, hey, illuminating the scene in different wavelength, and now you have absolute certainty whether it's a pass or fail. So how does it glow in infrared? How does it glow in ultraviolet? Again, not full deep ultraviolet, not full infrared, but enough. Basically what we call multi-spectrum camera. So this is RGB camera. You can have multi-spectrum that has like 4 or 5 systems, and that gives you perfect slice image, meaning there is no partial information. It says what is in the red, it is in the red. What says in the green, it is in the green. What is in the blue, it is in the blue. So this gives you perfect color sense, and much faster, because again, this is a computationally heavy thing. How heavy? During Olympic, people got some idea. It's like, what if we can stream this whole thing at 8K? It's like, why? But again, you want to, but here's the deal. You must have realized that's huge. 4K streaming is like 33 megapixel frame. Imagine 8K. That's bonkersly huge. How the heck you gonna crunch that much information? And doing that at broadcast quality and at 120 FPS. It's like, why? Well, broadcasts are only like 30 FPS or maybe 60, but why that? The idea was, whenever you see any sports match, generally the camera is capturing at much higher speed, and it's going into a server that we call cache server. So whenever something instead, like in cricket, is like that happens, the people who in the broadcasting room, they can pause the scene, go back to the cache memory and stretch out that 120 into 24, and then you'll get the slow motion. How the heck you do that for 8K broadcast quality? Again, no compute hardware is like fast enough, robust enough. They're like, okay, what if you don't need the compute hardware? What if you take it and you throw it and you just have RGB? So red, blue, green, the end, go home. So again, there was a time where this was super common in handycams, even early digital cinema cameras, and it was amazing. It's just that handycams got a shittier end of the deal simply because while the optical path, basically the lens, the sensor, they were awesome. It's just that compression of 1990s was idiotically bad. So we never got the true love that not having this would have given us. And nowadays, I have not seen any cinema camera that has this anymore. It's like we got used to this DeBayer fake colors. So industrial puppies are like, nah, bro. We say Coca-Cola red, it is Coca-Cola red. The end. So far more what we call faster and far more color accurate. So if you have a color chart and it has to pass it, it will pass it. And if there is an any minor deviation, it will detect it and it will throw it away. So they are costly. And again, they're not costly because of the electronics. Technically, they should be cheaper. And yeah, you might be like, what about those light prism? Not that expensive. Like again, you can buy this as a toy. So not that expensive. It's just that they're not sold enough. So, but they are unmatched, flat out. Like the end, there is no discussion. So if you're like this pharmacy, this has this sort of white color for this tablet, it will be that white color for the tablet, because it's making sure all the color weightage is exactly to your specification. Again, whenever you are using this, you actually put a sample, like make sure this sample is the pass signal. Any sample that is deviation from it is the fail signal. So they are very costly but unmatched, meaning if you really want good photos, that's how you get it. Again, it might not look good because again, these are mixed in such a way to make it pleasant to us. This is designed in such a way where it's like, no, it's accurate, not pleasant, accurate. Now we come to the reality. The biggest difference between industrial cameras and this sort of camera is that vision. Vision, again, for our human eye is a bit different versus computer. Now, computer is only designed to do one thing: pass or fail. There is nothing more than that. It's just like, hey, is the cap on the box? Yes, pass. Cap is not on the box, fail. The end. There is nothing more than that. It's not evaluating the color, the texture. It's a pass and fail machine. Everything that is going into it is just for that decision making, binary decision making, pass or fail. So it has to be accurate and trustworthy, but not pleasant. It doesn't. That's why I say, like, they will not complain, oh, it only has 8 stops or dynamic range. They're like, bro, fine. Oh, it's only 2 megapixel. Bro, it's fine. We good. We got this. No problem. And computers are also optimized for comparing. They are not optimized for, oh, we're gonna do RTX gaming. No, it's just like, take this image. And why they're using images in a computer rather than some analog circuit is just that if you have a box, serial box, it's a freaking box. It will have some deviation. So you can't just throw everything away. So you do need some computation to wiggle the real image and have some sort of forgiveness. So how much forgiveness? Camera helps you to get true data in. Computers helps you to limit it, so you're not rejecting everything. So computers are optimized for that, and they are only comparing with their own memory. That's why you will say, this is the box that we are gonna bring to the market, send it through the system, camera captures it, you set it as a master file, everything moves forward from that point. And the computers are designed to be robust and real-time operating system, meaning again, they are working with other hardware, physical hardware, compressed gas goes, throw away the item generally. So they are working with in real time. Everything is moving, it has to work. And they're not that powerful. Like Raspberry Pi is more than good enough. It's just that not robust enough. Computers here is like, it's a big industrial box. You open it up, it's like, ancient atom processor or something like that. They're not powerful, but they are designed to be, you put it and you forget it. Many of them have multiple power supplies, so you can have feed power from A to B circuit to C batteries backup. So again, they have to be running for years without any issue. So fundamentally, it's just a binary pass and fail. That's why the pleasantness of the camera is not important here. It's just that, can it be trusted to give, computers have this rule, garbage in equals garbage out. So can it be trusted? Yes or no? And many times you will use light box, because if you have too much outside influence, even if person walking back, it's casting a shadow, it will change the chromicity of a color, and computer will be like, okay, it's fail, it was not a fail. So you need to enclose the environment. Generally, if you see this sort of black box and all that around something where too much flashing is happening, yeah, that's an optical inspection statement. So that's why generally optical scanning is done in an enclosed environment. So you're removing outside influence. Okay, that's the difference. And again, I'm talking about all of this simply because to teach you one core aspect. Don't fight about color science. Do you like it? Yes or no? Are you buying equipment for yourself? Are you liking the output of it? Yes or no? The end. If you're like, hey, I'm using this camera and I'm giving my clients my output and they're happy with it, they're paying me money, the end. There is no reason, there is no essence of fighting. And again, be mindful, every human has different colors of eyes. Yes, our eyes literally have different color filter. Some people are sensitive to green, some people are sensitive to blue, some people literally see a different color. I'm not even joking. And again, some people may have a weak color. We know about color blindness, but there are some people who have literally weak sensitivity, which I did not know is a thing, but again, they do. So certain shades of red will not look good to them, even though it is good subjectively. So do not fight about color science. Learn from industrial puppies. So this was my presentation on basically industrial equipments. Hopefully you have liked it, learn from it. In that case, please hit the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me success from it. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.